So, three kinds of user-defined functions. Let's jump right into the first kind, scalar functions. The word scalar means a single value. Think of it as a ruler or a scale, and you want to find one particular value on that scale. And that's a scalar function. The key point of a scalar function is that it returns one value. Just consider it like one cell. Similar to a scalar function that's built into SQL Server, the scalar UDFs or user-defined functions will return a single value that can be used in any expression, any place inside a SQL Server. And they can be defined to accept as many parameters as you want. Within reason, I'm sure there's a limit out there someplace, but I've never run into it. So here's our first simple hello world scalar UDF. Switching over to tempdb, so it's just a throwaway function. Let me scroll down so we get some more room. The name of this function will be dbo multiply. It'll accept two parameters, a and b. Both of them are defined as a data type int for integer. And then right away we have to say what the function returns, and it returns an integer. Then there's the as. Create seems to always have an as after it. So we're creating function, here's the name parameters. It returns an int as. Then you have to have a begin end, and the last line before the end has to be a return. And all this function is going to do is return a times b. So it just multiplies a times b. The only purpose of this is to prove out how to create a function. Create it, and then within a very simple select, that will only select the one expression that consists of this function. We're going to select dbo multiply and pass into it a 3 and a 4, and sure enough we get 12. So that's just a real simple scalar function. A key rule about building scalar functions is that it must be deterministic, meaning that if you pass in a certain value, you can determine or prove out or always know you'll get back the same response. For this reason, scalar functions cannot include features such as getDate or newID or random, and they can't update the database because all of those capabilities might cause a scalar function, depending upon how it's coded, to not be deterministic. Using the OBX kites database, here's a couple examples of a function. This is the function getPrice or fGetPrice. And in the OBX kites database, there's actually a price history table for each product. So what this function does is allows you to say for a certain product on a certain date, what's the price? So switching to OBX kites database, if we say we want to get the price for 106 using today's date, it finds the current price, $131. If we say back on May 1st, what was the price of product 1001? Let's go ahead and open up this function and see the code inside. Opening Object Explorer, navigating to the OBX kites database, down to programmability, functions. Here's our scalar valued functions. Here's fGetPrice, and I'll use the modify this time. So here's the three parameters being passed into it. The first is the code, which will be used for looking up the product code, the effective date for which we want to look up the price, and contact code is if we want to look up and find what price applies to a specific customer who might have a special discount depending upon who they are, what groups they belong into, frequent buyer clubs, those kinds of deals. And because functions have to right away determine the data type they're returning, it returns money. Here's the begin and the end. With the return at the end, it's returning the current price. So the first select, if there's a parameter for customer, determines the discount percentage for that customer based upon their customer type. If the discount percentage was null, it replaces that with a 0 just so we don't have any errors later. It uses a subquery to find which date is the appropriate date in the price history table. Then using that date, it looks up the current price and calculates the discount, which is then returned.